Hi everyone, thanks for coming for this talk today on Momentum Season 2, and we're really happy to have with us AWS. We have Zach and Jack, with James and myself, and we're going to talk about super cool project, Doctor Who 60th anniversary, how we used NearTime on that. But first, we're going to talk about how it started with you guys, starting with AWS. So maybe first, everyone could introduce themselves, just so everyone knows what your role is at AWS.
Yeah, I'm Zach Willner. I'm a senior partner solutions architect, focusing on content production partners. This is right up my alley.
Yeah, howdy everybody. I'm Jack Wenzinger. I lead the global partner strategy for generative AI and content production, which means that I help build out our supply chain as it runs in the cloud for virtual production, VFX, animation, and film and TV file-based production.
And I'm James Uren. I'm the technical director at Mo-Sys, and I'm kind of, I suppose, the architect really of our NearTime system, which is a cloud-based re-render service. And of course, we're using the AWS cloud to render pixels for Doctor Who's 60th anniversary. Yeah,
perfect. And I'm Florian Gallier, in charge of strategic partnerships at Mo-Sys and partners like AWS and these great projects we're all doing together. Before we start talking about the projects, I was thinking it would be good for people who are here to talk about how it all started, like how it started the collaboration between AWS and Mo-Sys. Maybe we can, James, do you want to?
I'll take
Jack, you
Jack,
please.
Okay.
So it started in a dark time. The world was in a pandemic and we were all in fear. But Epic Games was starting something that was revolutionary, where they started the fellowship program for virtual production. James happened to be an instructor in that, and I was lucky enough to make one of the first classes for the fellowship. So, going through that and learning about everything that was involved in virtual production, I had always been on the engineering side, or partnership side, had never really dove deep into game engine technology, rendering, or virtual production. So it was fantastic to be able to get immersed in that. And strangely enough, the pandemic made that easy because there was nowhere to go. So we were able to spend 16 hours a day focused on this. And that was when James and I met. James, he spoke. He was talking about virtual production and some of the very interesting things that he was doing, which I hadn't heard anybody really talk about. I was always talking about production as far as how storage and GPU compute could be leveraged from the cloud, but I couldn't figure out a vehicle to actually make that happen. And when I started talking with James, we kind of hit it off, and we started talking, just as friends. And we were on a virtual happy hour. Sad, but James goes, "Hey, I got this idea. I just don't know where to go with it." And it was a cocktail. It's how all great engineering efforts start. It was on a cocktail napkin, and he's showing me this weird little diagram of leveraging. And James, you want to take it from there? You want to talk about your idea?
Sure. Yeah. So. Yeah, as Jack said, Michael and myself, we had this idea of a parallel near-time cloud-based render. So we talk about real-time rendering with virtual production, but the problem with real-time rendering is you're always balancing off your aesthetic quality with the performance of the computer. So you can only achieve a certain level of quality because you've got a computer that has to render it in 40 milliseconds, a fraction of a second. So, but a lot of productions have a post-production afterwards. Some don't. You have no choice with live production. You've got to take what you get. But in post-production, we could actually automate the re-render of those, of that Unreal scene. We could re-render it in parallel, and if it doesn't manage to render in a fraction of a second, that's okay, because we can wait for a near-time render. Now, what we want to do with that is we want to be able to scale that. We want to be able to scale it, and we want to be able to scale it very, very dynamically. And so that's where the cloud comes in, because the cloud is perfect for that. We could deploy a computer on premises to do this, but we can't deploy 100 computers on-prem to do it.
Exactly. And we're gonna explain how it applies to production, like Doctor Who, for example, and what it brings for the creatives on set as well, because that's what's interesting, that they can actually see this virtual world, but with in real time, and then you can have the quality of post production, right?
That's right. So I suppose after this initial conversation, this is where we sort of where I met Zach, and we and AWS supported Mo-Sys in building the initial versions of this cloud-based system. So Zach, I don't know if you want to talk a little bit about that.
Yeah, absolutely. So we're lucky enough to have our own media marketing team, and they were already invested in the Mo-Sys Star Tracker ecosystem, and they were interested in virtual production, and they were just dipping their toe in the water at this point. And we were really interested in creating more photorealistic scenes and shooting in 4K or greater. And we didn't have necessarily enough horsepower to do that in the 40 milliseconds like you're talking about. And the opportunity came up to kind of build and beta test this all in one go. We had these internal AWS projects that were a great test case to be able to build and iterate on the NearTime rendering system. And with relatively low risk, we still had to deliver some marketing content, but it was a good experience to be able to work hand in hand with you on also our marketing team, go on set, figure out what works, figure out what doesn't work, and in the end, be able to get a beautiful background plate rendered.
Well, in my role as strategy with AWS, is this work? One of the great things that I get to do is take a look at the supply chain, right? And you break out version into all of its individual components. You take a look at the individual technology leaders in the place, and you see exactly how mature the offerings are and where we can help, where we can help advance that technology so it's easier for customers to, leverage those tech. And then I get to work with great guys like Zach who are able to not only from a credits perspective or the partner program, but to lean in and work alongside the partners as they're going through. I think you once said it was easy. It was not easy. I still remember those 14-hour days of these guys sitting in the server room, going through pizza and beer and trying to make that virtual production work off the documentaries that we were creating.
And I think that the story is, from that napkin through alpha through beta, bringing us up to Doctor Who, where we were able to test in a less critical environment than a huge BBC show, and AWS just supported Mo-Sys all the way through that, through the partner program and through through those alpha and beta tests. So should we get into the meat of it and talk about Doctor Who?
Sounds good. And I think we even have some pictures of the behind
we do,
the scene.
yeah. So if we could just go to image 1 real quick, I just want to talk through the different effectively plates that we have here. So this is what the camera sees. So this type of virtual production, obviously it's not LED, it was a green screen virtual production, but it's still virtual production because we still design and build the 3D assets and do the visual effects in pre-production. So virtual production doesn't have to be about LED walls. In fact, in this case, in this show, they turned down LED for cost reasons and decided to go with green screen, but keep the virtual production approach. So with Star Tracker, which is, you can see it on these cameras here, it gives the position of the camera very accurately, and our software VP Pro, we can create a real-time previs, which is often called simulcam. So if we go to the next picture, we'll see what it looked like on set. So this is what the director, the DP, and the actors are seeing on the monitors. So it's not a perfect render, but you can see the alignment is perfect. You can see if we maybe could toggle back and forth between 1 and 2 here. So between 1 and 2, thank you. You can see the real set stops here and we continue in virtual. Now here, the blend isn't perfect. You can see there's a bit of poor green screen here. There's even a boom microphone coming in. But this is a previs. This is a simulcam to give the director, the DP, and the actors the ability to light the scene appropriately and to understand where they might have problems with green screen, to block the actors, and to figure out what shots are going to work. So we then record the camera movement, right? We record it very precisely inside VP Pro, and then we send it up to these guys. We send it up to AWS, to our service, which we call NearTime, that runs on AWS instances. So then those instances re-render the background. So let's go to the next one now, and we'll see this is the ungraded re-render of that tunnel, that spaceship. And this is from the 60th anniversary episode 2 from the David Tennant sort of mini-series done with Catherine Tate. Now, if we go to the next one, we deliver all of those bits and pieces to post-production, and this gives us this final composite is then done in Flame as a 2D composite. So you don't have to do a 3D composite with something like Nuke. You can use finishing tools like Flame to really speed up that post-production process.
Which is interesting as well is that we talked about pipeline earlier, like when you optimize and how, but for pre-production, it's really interesting as well because kind of you can block your shots and see what you want before even filming. So for the 3D artist, it really makes a difference, right?
Absolutely. And there's another partner we should mention here, which is Painting Practice, that worked on the pre-visualization of this show. And they're also using Unreal Engine. So they're able to render early versions and storyboards of the sequences, which then translates into when the visual effects company comes in, which the visual effects house was called RealTime. They can build the scene out based on the previs storyboards.
The other thing I always liked when you would talk about how, what's that?
It's back.
Okay.
Yeah.
Is how you would use the game engine on set to be able to light the set so that it just made things easier to flow once you did get to the final shot.
Absolutely.
And being able to work in Unreal means, like you were talking about patient practice, sorry, and when we collaborate with other entities, with other companies, it means you don't have to change your workflow as well. So if you're developing and creating in Unreal, then fine, we can use it because we all talks the same language in a way, right?
Absolutely. This is what is known as Unreal Final Pixel. So the actual pixels that were transmitted when this show went on air are rendered from Unreal. They're just not rendered in real time. They're rendered in near time in the cloud.
So you don't get those final pixels on set like you would with LED-based real-time virtual production. You get a rough mock-up of what it could or should look like. So it gives you the ability afterwards also to make changes. So sometimes if you're not as disciplined as you should be with the pre-production process, you can go back and say, oh, the car that we put in our AWS marketing video actually needs to be blue, not red, because the car manufacturer in the background said that that's the car that they're launching. And this is a real use case. We went and had a different color car, a different model in our Unreal scene, and we were able to go back afterwards, resubmit that render, and have our plates rendered in the right color car, which was otherwise we would have to reshoot the entire interview documentary series if we were shooting on a more traditional real-time virtual production volume.
Absolutely. That flexibility is really important. And of course, there are some techniques, with LED now where you can get a green plate as well, or you can get some more flexibility, but still green screen gives you the most flexibility, no question. I wonder if we just have a look at the next slide. There's a diagram here. No presentation from me is complete without a system diagram. Hang
on, the napkin was way better than that.
I mean, basically, this is the napkin, just redone. So on the right-hand side here, your left-hand side here, is the onset. So we've got Star Tracker tracking multiple cameras, feeding metadata into our VP station. Now, here our VP stations are these racks behind. On set, we might have a trolley with this stuff in it. And that's generating a real-time on-set previs, and that's what goes to editorial. That's what they edited for this Doctor Who episode. They can use the cloud then, if they need to make changes, to re-render certain parts in order to improve their editorial and to do post-viz. Then we use NearTime again behind Zach here in order to render the final program. And at that point, we're rendering 160 megabyte frames, multi-layer EXRs with all of the bells and whistles inside, like depth layers, ST maps, cryptomats, that make the compositing and finishing afterwards so much easier. And at that point, the really nice thing about our NearTime system is you can ingest an EDL. So you don't have to re-render everything. You just re-render what you need with handles. And then the last part of the chain here, and this is something, if we just go back to the Doctor Who, for those who didn't see this episode, there is a CG character that walks, a robot that walks up and down this spaceship, and that needed to be generated in Maya. So we have another pipeline as well for traditional visual effects, traditional DCC tools like Nuke and Maya and Houdini. So I think Houdini and Nuke were used to render, Maya and Houdini were used to render that robot by the visual effects house, but they could still take the camera data from set, the same camera data that's being used to render those backplates in NearTime.
And what's also really interesting for post-production is that, like you said, because we were recording everything on set, including lens distortion and all the aspects of real-time visual effects, they can also reuse that while they are doing post-production. So it's really, because sometimes we hear like, oh, there could be disconnection between real-time virtual production and post-production. So that's what we avoid. In fact, that's where we make it even more smoother workflow, and so it goes end-to-end production, right?
That's it, and it all starts with having a very accurate camera track. And you know, Mo-Sys is probably most famous for inventing the optical inside-out tracking system that's attached to this camera with the markers, the star tracker system, and by having that very accurate camera and lens information at the start, it enables us to re-render backgrounds in Unreal and also re-render in other tools. And it skips over that laborious step in visual effects where you have to match, move, or recreate the camera from your footage. We have that data already, and it's synchronized with time code, and everything just slots together again in your finishing step.
So I know that last NAB 6 months ago, we had a conversation about, we had just launched Deadline Cloud, which was the cloud rendering service. I'm just curious, what is the update there? Is there?
Yeah, well, it's moving. Yeah, so we have a prototype that works. So for those that aren't familiar with Deadline, Deadline is a render farm management service, basically. And AWS have recently launched Deadline Cloud, which is Deadline running in the cloud and managing a fleet of renderers. And so this made a huge amount of sense for us because we had to build our own render management service. We don't really want to support and maintain that. We'd much rather use Deadline. So since NAB, we've built a prototype. It works, I'm told. So very soon we'll be launching the next version of NearTime, which will entirely use Deadline for its fleet management.
Talking about Deadline and what's next, maybe you guys want to tell us a bit more on what's next and also what's next with our collaboration. I think that would be, I mean, as much as we can tell, of course.
Yeah, absolutely. So Deadline Cloud just launched Windows Service Managed Fleets, which will support the Unreal Movie Render Queue and other Unreal workloads and other Windows DCC applications that need to be rendered. So that's an important update that Mo-Sys will be taking advantage of in their implementation of Deadline Cloud.
Absolutely, and you know, we're obviously, you know, there's also a bunch of new instance types that are very exciting for Unreal rendering, which have larger GPUs and more capacity for Unreal rendering.
Larger VRAM on the GPUs is a huge thing. So we just launched the G6E series instance family, which has 48 gigabytes of VRAM per GPU, and you can get an instance that has up to 8 GPUs. So you really can take advantage of a lot of horsepower there, both in cores, vCPUs, and GPU cores and GPU memory.
And I have to say, I would have loved to have had that when we did this show because we had a lot of problem with virtual textures not having enough memory to load in. So yeah, no, obviously everything's getting better, faster, stronger, more powerful, and yeah, we'll continue to take advantage of those and speed up those renders. At the moment, we're able to deliver a NearTime render back 20 to 40 minutes after the take into Frame.io or to an S3 bucket or to Moxion. And we see that will improve as the instance types that are made available through AWS improve. We'll be able to get that time down even further.
Yeah, and Deadline Cloud also supports spot instances, so you can essentially define roughly what you want in your instance type. Maybe you specify a couple GPUs that could support this workload and a range of memory and CPU, and Deadline Cloud will automatically select the available lower price spot instances for this rendering. So it also will support scaling to tens of thousands of nodes. We recently had a customer push the limits up to 560,000 vCPUs for a single render job. So that's pretty nice. So you'll get there soon.
Yeah. I think for this show, at one point we did have 100 nodes running at once, but that's as big as we've got at the moment. We haven't got to the thousands yet.
With GPUs, though. That's the big difference. The GPUs are doing the heavy lifting here, right?
Of course they are. Yeah, absolutely.
Well, and more broadly, from a supply chain perspective, you may have seen we just announced we did a collaboration project with ITV and BBC, Adobe, Cutting Room, where we're trying to improve the overall supply chain capabilities of film and TV production. We leverage the BBC Research Labs. They have a GitHub project called TAMS, which is time addressable media storage. And essentially that, we're just continuing to make it easier for customers to be able to control the entire supply chain in the system. And it would be great to bring in virtual production into that project.
Absolutely. Very keen to get involved with that. And we'll certainly be taking advantage of the new instance types as they become available as well.
That's what we're looking forward, and we will present probably at NAB the next project we worked on together, and we'll be able to talk more about it there. Well, thank you guys for coming. It was great to have you and great to be able to finally show some footage of Doctor Who and show you in exclusivity some behind the scene for the panel. So really great, and thank you guys.
And thank you so much for trusting us with your ideas. We appreciate
thanks
it.
for the support.
Thank you.